Hi everyone, welcome to another series of Foundry virtual events. My name is Joyce, your virtual host for today. I'm here today with my colleague Martin Mayer, Head of Creative Services here at Foundry. So Martin will be covering some of the live questions after the webinar, and hopefully we'll be able to cover all of them. So before we dive straight into our session, I just wanted to go through a couple of updates with you guys. So we have over 42 webinars on demand. For more information on where you can find those or to register for those, please go onto our foundry.com/events page. For any questions, any feedback, or you wanted to participate in virtual events next year, you can send us an email on virtual.events@foundry.com. So we are nearing the end of the year, so we have a few more upcoming schedules. So we've got the next one coming up on an introduction to practical compositing with Austin Mayers. So just to let you know, this has been rescheduled from December the 1st to December the 8th. And then our final webinar will be collaborate remotely on Animatic with Flix and Storyboard Pro on December the 10th. So for more information on those and how to register, please visit our events page. Our Foundry Learns page keeps a lot of documentation, release notes, dev docs, and new training documents as well as some tutorials. For more information on how you can grab those, you can go onto our learn.foundry.com page. Follow us on all of our social media channels for any industry trends that within the VFX industry. We also have a Insights Hub hosted on our web as well, where we have a lot of industry articles. We host a lot of artist spotlights as well, where we highlight specifically artists and their backgrounds and how they have achieved what in the career what they have done. And also we have some industry trends article as well that you can have a look at. So please visit our Insights Hub when you have some time, and you'll be able to download all of those. So speaking of learning, we have recently just collaborated with Austin Mayers, who's put together some very fundamental compositing tutorials together. So for more information on where you can download those, you can go onto our learn.foundry.com page. So more training. So we've got new training for our community as well, compositing, Nuke and CG masterclasses, as well as training, one-to-one training as well with Josh Parks. Josh Parks actually did a webinar for us late September called What I Wish I Knew in Nuke, where he kind of walked through some of the fundamentals within Nuke as well. For more information on the coaching, the one-to-one training, or some of the tutorials or templates that he hosts as well, you can go onto the website compositingpro.com. And I will make sure to leave all of these links in the chat as soon as we've finished here. So lastly, calling out for all the students, we do a first year free licenses. This is for you to explore all of our Foundry's creative software through the first year free program that we provide. And this is for you an opportunity for any new students to experiment with Foundry products for 1 year free of charge. So that would be within Nuke Studio, Mari, Katana, and Modo. So for more information on that, you can go onto our education page, /first year free. Lastly, I just want to say a massive thank you to all of our studios, freelance speakers, and artists who have so far participated in virtual events. Thank you so much for sharing your stories on our platform, and we're looking forward to building up the slide more with more logos next year and more stories. So if you're listening in, thank you so much for joining us, and we hope we can work together with you again in the future. So that's it for me. Thank you again for joining. Let's dive straight into the webinar.
Hi everyone, and thank you for joining us today for another Foundry Skillet presentation. Today we'll be talking about the Smart Vector tools in NukeX. I'm sure many of you have heard of Smart Vectors, but I hope that for many of you this will be the first time you'll be able to see the power of Smart Vectors. My name is DJ Matias. I'm a creative specialist at Foundry. As a creative specialist, I get to visit with different studios and demonstrate the latest and greatest features of not only Nuke, but also Hero, our timeline review tool that's included in Nuke Studio, Mari, our texture painting software for 3D models, and Flix, our collaborative storyboard management software. I'm joined today by my colleague Martin Mayer, Head of Creative Services for EMEA, who will hopefully be able to answer the questions you may have. Thank you for your assistance, Martin. Speaking of questions, please enter any questions in the Questions tab. so that way we will be able to see them clearly without them getting lost in the chat window. On today's agenda, we'll briefly take a look at the history of smart vectors, looking back to see how far we've come. Then we'll jump into some examples for each of the tools in the Smart Vector toolset. And finally, we'll end up with some unconventional examples of ways to use smart vectors. So let's go ahead and get started. Smart vectors were first introduced in 2016 with the release of NukeX 10. Consisting of only two nodes, the Smart Vector node and the Vector Distort node, smart vectors changed the game when it came to match moving visual effects to a shot without the hassle of having to track the shot. A single frame of paint would now propagate throughout their entire shot. Right from its inception, smart vectors began to evolve from the feedback of its users. In NukeX 11.0, the smart vector node added the output to write ability, so users were able to render the smart vector data on a background thread, meaning one less coffee break waiting for it to render in the script. The Vector Distort node added the ability to blur the smart vector data, which helped correct microdistortions in the finer details. The following year in NukeX 11.2, additional controls were added to the smart vector node that included a strength control and a matte input with in-paint ability. The Vector Distort node saw a redesign of the properties panel for a more intuitive user interface. Both nodes in this release were also GPU enabled for quicker in-script processing. Within the same year, the Smart Vector family in NukeX 11.3 introduced the Vector Corner Pin node. The Vector Corner Pin node brought the familiar functionality of the Corner Pin node, but was GPU enabled and driven by smart vector data. 9 months after the introduction of the Vector Corner Pin node, NukeX 12.0 gave birth to the Grid Warp Tracker node, expanding the Smart Vector family once again. The Grid Warp Tracker node, also driven by smart vector data, added the flexibility of multiple adjustment grids that enabled a non-destructive workflow. The release of NukeX 12.1 brought forth the ability for users to export the Grid Warp Tracker points as either an independent tracker or transform node, thus giving users more options to expand upon their tracking and match moving workflows. Show me the smart vectors. So let's go ahead and jump into some of these examples of our smart vector tools. For today's presentation, I'll be working in Nuke Studio. If you're not familiar with Nuke Studio, it's basically our timeline product hero combined with NukeX. So it allows you to work within the timeline, see your shots in the sequence, and then be able to create comps from the timeline and jump directly into the node graph. Now, you don't necessarily need Nuke Studio to follow along with this, but you do need NukeX because smart vectors are a NukeX specific toolset. Let's go ahead and jump into the node graph. I'm actually going to switch over to a compositing workspace that I have set up. Now, this one's going to be a little bit different from what you're used to using NukeX, and that's because I have this little asset browser basically for all the assets I had in my project. Now I'm only able to use this just because I'm working with the Nuke Studio. It makes it super handy, if you do have a bunch of assets and you're trying to build comp scripts and you need to just kind of throw stuff in there. All right, so for this first shot, we're going to take it real slow, start off real easy. All we really want to do is first we're going to take a look at our footage, what we have to work with. Fairly low action shot, not much going on except for a head movement. But what we want to do with this one is take this tattoo over here, duplicate it, and put it on the other side of her for some symmetry. So let's take a look at maybe the best shot there, or best position that might be in. You don't want to do this one, can kind of see her shadow encroaching on that, so it's not really the best lighting for it. So maybe something like that when she moves her head. In this particular area looks pretty good. We'll just start on the last frame for this one. So there's a basic structure for setting up smart vectors, and we're going to start off by creating the smart vector node, right? And we're going to plug the source into source. And now for this particular example, it's going to depend on the footage and what you're trying to accomplish. But for this example, we're just going to use the Vector Distort node. We're also going to cover the other nodes as well, but for now we'll just start with the Vector Distort. So I'm going to add in a Vector Distort node. Pop that on there. Now you think that this source might go into this one that you're viewing, but that's not what you want. This is going to be the patch or the additional texture that we're going to be adding on to our original source. The way we're going to add that on there is we're going to merge it over our source. I'm going to create a merge node by pressing M on the keyboard, connect that to my source. If I view through that now, we're not really going to see anything because we haven't added in the source there. Let's view through our source there. Now we need to kind of pull a patch off of this particular frame. What we'll do is let's first put this down, some room, extend this out. Try to keep a clean script from the beginning, nice and organized. I'm going to add on a keyer. Just pull a simple key, try to pull that information out from the shoulder there. You view through the keyer now, alpha channel pressing A, and try to isolate just that information over here so we can pull that off of her body. Get a nice black and white, something like that. That's pretty good. So this is just going to be a first pass, and remember, first pass doesn't mean final pass. I think that's pretty good right here. We'll start with this, and we'll make any changes if we have to. From here, what I'm going to need to do is kind of create a roto just to isolate that out, get rid of everything else. Just create a roto off of this. Now let's go ahead and pull that off of there. I'm going to put that in there as a mask, so that way I can know what's going on. We'll just mask this. Great, that's what we want. Now what we want to do is kind of invert this. So I'm going to go back to my keyer and select the invert button just to invert that. Great, so now we can use that to kind of just pre-molt off of the original source here. So I'm going to add on pre-molt. Going through the pre-molt, I'm going to take it out of alpha mode, go back to RGB mode. There we go. I have a pretty decent first pass kind of patch of this. So let's see how this plugs in now. We'll plug in our source to our patch that we just created, our new tattoo area, and we'll view through the merge now to see what that looks like over the original footage. Of course, we don't see anything because it's laying directly over top of it. But what we want to do is put it on this side. So from the pre-molt, I'm going to add in a mirror node. I'm going to flip this horizontal. So that way we can see flipped over there. Now it's mirrored. And we're going to also add in a transform node so we can position that in place. Let's move this pivot point. It's offset here, down to here. I'm holding down Control on the keyboard while I move this. There we go. Now it's going to make it a little bit easier just to position this where I want it to be. Based off of that center point. Okay, good. So that's about symmetrical to me. I'm just eyeballing it at this point. Now we may notice a little bit of a color difference. Even though this is the same patch that we pulled from over here, you can see the coloring is a little bit different. Now it has something to do with basically this being the background here being a little bit darker and the background over here being a little bit lighter. So it's kind of just same colors but appearing differently. But what we're going to do to compensate for that, maybe just add a grade node, bump up the gamma a little bit just to kind of eyeball it, get it in the same range as the other side over there. Okay, good. All right, with that set now, basically pretty much done for the most part. And I say for the most part because I'll show you why. But for now, let's just take a look and see what's going on with this. We're viewing through the merge node. We go ahead and press play. Close out these properties panels there. We'll see how this looks. So it's going to have to calculate the smart vector information. Starting from 1, going all the way to all these frames here. Because we started at 150 as our reference frame. I'll show you what the reference frame means. So in the vector distort, we have a reference frame. And that's basically where we started our smart vector information from, where it's going to be referencing the best frame that we created. Now you notice if we look in on this, that we have all this distortion that wasn't here at the end of the frame. It's nice and clean there for the most part, but when we start at the beginning, it's all distorted. The reason being is because our reference frame is so far away from that one. So what's happening over time is the smart vector information is distorting a little bit and it's causing these micro distortions. So if we look at the smart vector node itself directly through there and we check out that information, smart vector, this is what it looks like. Play it. You can see it doesn't really mean much to us. We can kind of see the model itself, but the computer knows what's going on here. With the smart vector settings over here, we can try to increase the detail, if it's not holding to the actual model specifically. Of course, when you increase the detail, though, it's also going to increase the time it takes to process per frame. So it's going to be a trade-off of performance versus quality. You're going to just have to balance that with the best settings for your particular footage that you're working with. So I don't really need this at 1 right now. We'll just put it back at the default, which is 0.3. The strength is the amount of influence it's going to have that the detail is going to imply on this. So if I turn this all the way down, we're going to lose some of that strength or the influence on the smart vector information. The mat basically allows me to plug in a mat or roto. We might come across another situation in another example here, but it's going to allow you to, if something was passing in front of this, that object would be dragging these motion vectors along with it, and it would be smearing this. And if you want to avoid that, you can kind of roto out that object by adding in a mat, and that'll allow you to do that, kind of block out any occluding information. Of course, you can write out this information rather than processing it through the GPU. If you want it a little bit quicker, just write it out, then you'll always have that smart vector pass. Under advanced, if it is flickering lights, it can try kind of compensate for that. Different shadows may be off and on. And then the tolerances as well. You can set the tolerance of how much weight you want, say the red, the green, or the blue to affect this particular smart vector. So leaving these to default, let's go back over to, we'll first change it to RGBA so we can see what we're looking at. Use the merge node. Now we'll go to the vector distort node, and we'll talk about how we can take that smart vector information, and what we're going to do is we're going to blur it now, kind of smooth it out. So we have this blur option on the vector distort node. So you'll watch as I turn this up. I'm going to smooth out those lines for us and kind of pop it back into its original shape for us. So it's smoothed out that smart vector information we were just looking at. The very basic setup, once again, just adding the smart vector, vector distort to this situation, and then merging that information back over top the original source. So let's go ahead and try a different example now. We'll bring in this one from our bin over here. So if we take a look at this, we can see she has some face tattoos. Maybe we want to remove these now. So in the last example, we added information. Now we can actually remove it fairly simply in here. So we'll look through our footage, try to find the best frame where it exposes the most information. And we'll just start at the beginning around here. Everything seems to be more in focus than it was at the end of the thing. Okay, so let's once again start with our basic structure. Now, if this is a common process you want to do over and over again, you can create a tool set like I have out of smart vectors. So if I go to demo, smart vector tools, kind of just put them all together, and so that way I can just connect it and then select the tool I actually want to use. So we're once again going to use the vector distort node. So I don't really need to use grid warp tracker corner pin. I can get rid of these ones from here for now. Bring that down so I have my structure. So for this one, what we're going to do is paint these out. So the way we're going to do it is use the in-paint node that came in with the 12 series here. What we want to do is we'll first let's go ahead and create an in-paint node. I'm going to attach this to the source, connect it to the dot or to the source itself. I'm going to connect it to the dot, so try to keep it organized as we move along here. That's going to be right above it, coming up there. Got another dot here for this smart vector. Now for the in-paint node, this almost acts like the Photoshop healing brush tool. So anywhere that I'm going to add a roto paint, anywhere that I paint some alpha information, when I have it connected to this mat here, it's going to fill in with the surrounding pixel information here. So what I mean is we'll go ahead and take a look at this, the in-paint tool. I want to set this to actually, my fill region is going to be matte alpha because I'm using matte information from this rather than the alpha that's contained in the source. And then I'll begin by creating some paint strokes here. So paintbrush, get a little bit bigger, and we'll begin painting out some of this information. Great thing about this in-paint node is because it's just sampling the surrounding pixel information around it. As the light changing or shadow changes happen across the face, if it moves, so will the information that's being filled in here, as it is just reading the surrounding pixel information. Now, if for any reason you don't have a good texture or good detail from the surrounding pixel information, you can also put in your own little detail map here, and that'll fill in with the detail on that. But we'll just work on this side of the face for now. All right. So now that we have the RotoPaint information in place of where that wants to go, I can't simply just take this source and plug it into here, and I'll show you why. We'll go ahead and do that just for demonstration. This is not what you want to do. So now if we view the merge node, so what it's doing is taking its time to now processing through the smart vector information for this particular shot. That's why there's a little bit of a lag here. There we go. So what's going on here? What's happening is, because it's all warped looking like this, is because we're taking its own image and putting it over itself going through the smart vector. That's not what we want to do. All we really want or care about are those paint strokes that we created for the in-paint node. So let's actually try that instead by connecting this source to our RotoPaint information that we have here. See where that lands on the face. Click the alpha, make sure there's alpha there. Okay, great. Then this is going to go through our vector distort node. See where that landed. Make sure we're in the right frame. Oh, so you want to set our current frame to 1. There we go. So if you ever don't see your effects showing up, just check that you have the correct current frame set for the reference frame. That looks like it's in the correct position. But what I'm going to do now is, rather than reading this matte from here, I'm going to read it actually from the vector distort, because I know that's going to be warped according to the movement of her face. So I'm going to put another dot node here. Let's connect that there. All right. Now that's in place. Now I'm going to lay that over top. So if we look through this in-paint node, yay, we still have our source there that we want. Probably going to need to add on a frame hold here, because this is just for a single frame. I'm going to add in a frame hold so we know that it's not going to change over the time. And then we'll take that in-paint node right here, look through that. So in this situation, we don't actually need to merge the paintwork over the source, because we're already looking through the in-paint node and it has the results that we desire. Let's go ahead and play through this. We'll see the magic happen. Before we do that, I'm going to go ahead and get rid of this so it doesn't confuse anyone. For that, then we can over this a little bit more. Back. And now let's see the magic happen. Go ahead and play through this. Check our results. All right, so it's looking pretty good. It's a pretty quick, simple setup that we did here. Single frame of paintwork to cover this up here, some of these tattoos. It held for the most part. You can maybe see some of it bleeding through as she moves along. So that's where we'll have to go back, maybe touch up some of the rotos, extend them out a little bit more to really grab all that. I think that's pretty successful first pass on that. Really quick setup. So let's move on to a situation where vector distort might not work for you. And that would be a situation where you have footage like this. So it's going to be kind of troublesome, and we'll see why. Take a look at this. Have our basic structure set up. Smart vector, vector distort, and then bridged over the original source. What we're going to do is we're going to add on the Nuke logo to this orange here. Take a look at that. I already set this up ahead of time, just so we can see what's going on here. Now, as it comes to the edge here, one of the problems with the vector distort as it runs into the edges and comes out of it, it begins to shear. It begins to pull those pixels, as you can see here. Not only that, is we're also getting some warping over time here of this. It could be a situation where we'd want to maybe add some blur, but that's not even going to help our pixel pulling in right here. So if we were to kind of tackle this using just vector distorts only, we'd have to have multiple. Take a look at this. This one just has the logo opacity turned down. But it's a little bit better results, and the reason being is because we've added in multiple vector distorts to try to get this to happen, to prevent that pulling information as it comes close to the edge and as it pulled away from the edge. So if I open this up and we'll take a look inside this group, this is what that looks like. So you can see we have multiple vector distorts going on here. We have merges that are turning off and on at certain frame ranges. So it is kind of a process if you're going to do it that way. But I'll tell you right now, there is a better way, and we'll get to that. So that's it for as far as vector distort node goes. Now we can go ahead and move on to the vector corner pin node. Jump back into my timeline here. That's the vector distort examples. Now let's go ahead and move on to our vector corner pin examples. All right, so let's go ahead and check out what we have to work with in this example. Looking at my footage, full screen this. Let's take a quick look. So this side of the building here looks like a nice place to maybe add some paint work or do some cleanup on this, clean this stuff up, or add an image over it. So we're going to add an image over this. What I want to do first is pick a frame where this wall is flat to camera or straight onto camera. Let's go find where that's at. Maybe somewhere around here. Looks pretty good. We'll go with 130. All right, so let's go ahead and set up our basic structure for the Smart Vector toolset. I'm going to call in Smart Vector. Attach that to my source. And then we're going to be using the vector corner pin. And then once we're done, or once we add in our source to this, we're going to merge it over top of our background footage here. So let's add a merge in. Let's just pick something from our bin that we can use as an image to put on the side of the wall. Earth, we can use some graffiti. But we use this Mona Lisa, a nice painting on the side of the wall. We'll take this image, and before we do that, let's actually set our pins to the size of the image or to the input. What we want to do is just open up our vector corner pin node, go to the From tab. We're going to click Set to Input. And what that's going to do is going to take all of these pins that are set here by default in the vector corner pin, and it's going to set them to each corner of our input. That's what we want, so we can move the entire image. So I'm going to hit Set to Input. Notice it pops those corners to the edges or the corners. And then now we come back to our main tab, and we want to copy those pins that we just set on the From to the To. We'll copy. That's those pins for us here. If I look through our merge node now, it's a little big. We got to reduce this image, so I'm going to select all my pins, hold down Shift, and then drag and string proportionally, and then position this onto our wall. Zoom in on here. Now, if I were to try to play this right now at this point, I'll do. We'll see what happens. It doesn't stick with it. The reason being is because we haven't defined the placement of this image and where it should stick to. So let's go back to our original frame that we created on 130 and get this to stick. Now all we have to do is add in a keyframe or play through this now. There we have it. So as simple as that. Simple 3-node setup with 2 inputs, source input and then this painting input. If we go to the head of the shot, remember there's that extreme kind of perspective change. Let's see how that looks. All right, looks pretty good. I created a nice perspective for us. Maintaining that. Go ahead and stop it right here for now. So we can see some micro distortions going on here. We'll address that in a moment. But let's go to the header shot where I saw some other issues. And that would be, you can kind of see the artifacting from the image. We want to get rid of that. What we can do is just turn off the merge node, or like disable it, or turn down the opacity, key that on and off. So let's pick a frame where we would actually start to see something on the wall. Maybe we'll go right about here. So we'll leave this as the on frame. Let's go to our merge node now. I'll just set a key for this, and then we'll go back a frame, turn that off. Great, so now we've gotten rid of the artifacting that was going on there. Look at this as we play through it. And we'll go ahead and address some of the warping now, or the distortions. So if you remember from our vector distort node, we had the blur where we could blur the smart vector information. We have the same thing under our smart vector tab here for the vector corner pin. Once again, just turn up the blur knob. We'll see what kind of results we get. You can kind of see it's smoothing out these edges, but it's also creating this effect up here now. But for now, let's just turn this off, and I'll show you another method we can do to try to fix this distortion. Basically, all you have to do is add in a new keyframe. So we'll add in another keyframe. When you add in keyframes on the vector corner pin node, it'll interpolate between those, maintain your image for you. So cleaned up those distortions, cleaned up that edge corner up here, looks pretty good. Go ahead and play through this. Anytime that happens again, we'll just add in another keyframe just to kind of straighten it out for us. All right, so I think at this point, it's pretty good for a first pass. We will now just kind of add in a little extra to blend this onto the wall and into the environment a little bit better. Let's just do that. We'll go to our reference frame and start on that one. So now she looks like she's been weathered a little bit on the building for a while. It's definitely into losing some of the paint. It's chipped away from the weather. Go ahead and play through this and see what it looks like now. Looks pretty good. Let's go and move on to our next example for the vector corner pin node. I have it already set up just to show you a roundabout way of doing it. So we'll take a look at the footage. Here's what we have. Footage, make sure the right frame range. What we want to do is replace this sign with something else. So we got a lot going on in this image. We got some camera motion, some rotation. We've got the sign that's rotating as well. One thing to pay attention to that you might not notice but will affect your results is this little shadow here. So this is kind of a moving across it. It's going to affect the way the smart vector sticks with this particular panel. Let's go ahead and take a look at what's been done so far. For this one, kind of start off a maybe more traditional approach. What I did is did camera tracker. From the camera tracker, solve that so that way I can get kind of stabilize my image. So if you look at the stabilized image at this point, then from here I also tracked it again for the rest of the camera stabilization after it was that. So let's take a look at that. Now we have a more stable image to work with. Okay. From here, proceeded to do my rotos to hold this out, and then added in my vector corner pin node with my source. Then we came back through, look at it right here, the merge node. Okay. Then what we had to do at this point, can't leave it like this because it's not fitting within frame. Had to reverse our stabilization. So we inverse vertical transform, the tracker, basically brought it all back to where we started from, but with that information on it now. So all that was a pretty lengthy process, creating rotos, hold stuff out and whatnot, and doing the tracking. But what we can do instead, I'll show you the example of how this would work if we just went directly through the corner pin node and the smart vector tool. So we'll bring this up here. Let's connect this from our rest of the pipe down there. and we'll go about it a different way here. Once again, starting with my foundation. So, because of all this motion that's going on in this original shot, it might be difficult to work with it normally without actually stabilizing it. But we'll try and see what happens with the vector corner pin node here. What we'll do is create a source or add in a source. And for this, let's use the checkerboard. Easy enough. I'll look at it over this right now. Doesn't fit. Remember, we have to set our pins to our input. So let's go to from, put the input, copy those from there. And now we can adjust our pins, fit the area we want to cover up. So we'll just put these right in the corner. Somewhere around there. Right? Probably won't get it perfect here. Not to take up too much time with these details. Just to give you an idea how this works though. All right, so looks good. Remember, we have to set our corner pin frame, tell it where we want it to be. Now we'll go ahead and play through this, see what kind of results we get. Okay, you can see some warping going on here, some distortion, it's fine. What we're going to do is when that happens, we're just going to add in keyframes for that. So let's go ahead and add one at the beginning of the shot. I'm just going to do on every 20. But even though I can't see this corner, I can still see my edges of where this should line up. So I just want to go for the edges. This edge up here, same idea. You can see the corner, but we can still see the edges. So you can see that this one takes a little bit more setup than our last example, but this footage is definitely more dynamic than the previous example was as well. So for the amount of work we're doing here, I'd rather do this than apply this same technique or add in a source. And for this, let's use the checkerboard. Easy enough. I'll look at it over this right now. Doesn't fit. Remember, we have to set our pins to our input. So let's go to from, put the input, copy those from there. And now we can adjust our pins, fit the area we want to cover up. So we'll just put these right in the corner. Somewhere around there. Okay. Probably won't get it perfect here. Not to take up too much time with these details. Just to give you an idea how this works though. All right, so looks good. Remember, we have to set our corner pin frame, tell it where we want it to be. Now we'll go ahead and play through this, see what kind of results we get. Okay, you can see some warping going on here, some distortion, it's fine. What we're going to do is when that happens, we're just going to add in keyframes for that. So let's go ahead and add one at the beginning of the shot. I'm just going to do on every 20. But even though I can't see this corner, I can still see my edges of where this should line up. So I just want to go for the edges. This edge up here, same idea. You can see the corner, but we can still see the edges. So you can see that this one takes a little bit more setup than our last example, but this footage is definitely more dynamic than the previous example was as well. So for the amount of work we're doing here, I'd rather do this than how I showed you this other setup with the tracking and stabilization. This one's just a matter of just setting these pins in the correct position for us. So now let's go and play through this and see what kind of results we have after setting these keyframes. I'm going to full screen this. And let's see what this looks like. Go back to the beginning and play through. I don't expect it to be perfect, but it should be pretty close. All right. Seeing that warping because that shadow that came in, as I mentioned earlier before we started that. We're going to need to create a roto over this to hold that out. For the most part, that grid sticks pretty well. So we just need to address some of this warping here going on. So let's do that. First thing we'll do is we'll go ahead and kind of roto this out. I'm going to go back to the end of the frame here, or the last shot, or the last frame here. This is where most of the sign is revealed. And do just a regular planar tracker. Okay, great. That's tracked, and now let's add that in as a mask for this. Now we can address some of the warping that's going on with the image itself. What I'll probably do is I'm going to start off by lowering or changing the detail and the strength on this. But because I messed around with it before, I know that probably the ideal settings for this one would be 0.5, and then so I just went with 0.5 on the strength. So we'll see how that works out for this, what the results look like. All right, so that's looking a lot better with those settings. But we still have this issue over here. So this is where the mat input comes into play. So when you have stuff occluding your area that you're trying to work with, what you can do is add a mat over that. It holds out that information and it doesn't affect the underlying image. What we'll do is we'll create a roto around guitar. Go somewhere right here. The great thing about this too is it doesn't have to be a very tight roto. It can be kind of a garbage roto. Not just the guitar that we need to worry about, but remember it's that shadow we want to worry about. So I'm going to look through the original footage here, original source, and I'm going to roto out shadow area also. You can see that I'm not sticking very close to that shadow. It almost works better if you don't provide a nice tight plain roto. That looks good right there. That's fine. Maybe we'll add some blur on this just to smooth that out. Bump this up. 30 is fine. Okay, we'll put that as our input for our smart vector mat. And what we want to do is view through there. Remember to set your mat input to mat alpha. And we can choose to inpaint this. Inpainting is just going to fill in the surrounding pixels of this with that information in there. So we'll go ahead and inpaint that. And now let's see what kind of results we get. Oh, actually, before we do that, I'm going to need to kind of just keyframe this roto really quick so that way it follows with the footage. Because it doesn't have to be perfect, we can just move it very quickly. All right, so that looks like it holds pretty well with it now. Okay, now we can look through our end result. That bigger. It's much more stable now with that rotor that we added as the mat input for the smart vector. And it looks like it came off there in that frame. So let's go find that frame again. Towards the end here, it starts to come off at the furthest point. Be right about there. And we'll just add in another keyframe on the vector corner pin node, this frame. That's pretty nice, you know, for not having to do too much work on this. Basically just created smart vector corner pin, added some keyframes to that. Just set these pins in the right place as it progressed through over time. And then we added in the roto to roto out the image as it came across or over this sign. And then we also added in the roto for the smart vector information to hold that information out. This was a lot simpler process, and you can see it's a lot cleaner. And this performs a little bit better as well. It's not going through all those things. So finally, on this vector corner pin example, we'll revisit these oranges. I told you there would probably be a better way to do it rather than the vector distort node. We take a look at what we have for the vector corner pin node. We'll see what this looks like. Give that a second to load up. Start back at the beginning of that. There we go. If I play through this now, we're going to see what kind of results we get out of this. So as you can see, vector corner pin node isn't the answer either. You're still getting that problem with when it gets to the edges of that pulling the image or pushing the pixels around. You would have to do is probably set up multiple vector corner pins, and that's not fun. So what would be probably the best way to apply this same technique or the same logo to the oranges? Well, probably the most simplest direct one, and that's just adding transforms. Basically, add a transform to place this in place, another transform here to kind of use it as the access point and have it rotate around. So if we look at this point, play through it, doesn't pull pixels, it doesn't push the pixels, stays right with the footage, and it processes a lot faster than it would going through Smart Vector and Vector Corner Pin or Vector Distort. The reason why I showed this is just to kind of emphasize that you want to use the right tool for the right job, the right situation. Now, Smart Vectors may seem tempting just to use for everything, but like, oh, it's going to solve all my problems. Not necessarily. There could be quicker, faster, easier ways to do these things. Just got to remember that there are other tools you can use, and in Nuke, there's multiple ways of doing something. This one just happened to be the quickest, fastest, and get the best results by using these transform nodes. Now let's go ahead and move on to some of our grid warp tracking examples. Let's switch right back over to compositing space. This first example here, we have a puppy, and it's actually composited over a brick wall sitting on some grass here. Now for this one, we're going to use the grid warp tracker maybe to enlarge some of the features of the puppy dog, maybe his eyes and his ears, give him a little bit cuter look, or maybe change his look altogether. Let's see what we come up with. Let's start with our green screen source. So that's going to make it a lot easier for us just because it's on the green screen. Trying to take a little bit liberty of as far as where we're going to be drawing our grid. Call it Smart Vector. And we'll be able to key off the green screen without having to worry too much about doing some nice rotos around the dog's head. There's a few inputs on the grid warp tracker node itself. We have the source input, goes to the source that we're working with. The Smart Vector, of course, is a Smart Vector. This destination one can be for an additional input. We also have the mask input as well. Taking a look at our properties panel for the grid warp tracker, we have a from grid and a to grid. So this is like source and destination grids. For the from grid, we're going to start with that. What we want to do is we're going to draw an area using this little icon here, this tool. We're going to click and drag over it of the areas that we want to warp. We'll do the dog's head. So you can adjust these divisions over here with the slider, add more of them, take away some. You can even add some manually if you prefer. Start with the basic 2x2, then you add some in by going to this pen icon with the plus. You'll see a red guideline pop up of where it's going to be placed. Now what we need to do is actually track this grid. That way you have the tracking information and the points can follow. It's going to be driven by the Smart Vector. So we'll go ahead and track this, but actually I already have one tracked to save us some time. So I'm just call this in here, swap this out. That. Now if I'm looking through it, let's open up our grid warp tracker. Play through that. So now you can see there's some warping and distortion going on here. Now the reason being is because as it tracked from the from grid, it moved those points around. And these points are trying to compare itself to the to grid. So this is the result of the from grid moving away from the to grid point. So it's this point to this point to cause that warping. Not to be alarmed though, all we need to do to kind of correct this and give this something workable that we want to work with is basically we can either link this grid to grid, like pressing the link button. We can right click, copy all keys, select the to grid, and then paste on there as well. And you'll notice that as I do this, grids will pop into alignment with each other and source will look more normal. There we go. You'll notice the grid itself is set over a black background. So the grid warp tracker has an internal merge system. It's pretty much the same as if I were to change this background to over source, it's like adding a merge over source. So it'd be the same as if I were to add this merge, A over B. And we'll look through it that way. I'll turn this back to black. You won't notice a difference. Another reason why you might want to do something like this is if you have to add in some nodes in between the grid warp tracker and laying it over top of the source. So maybe we had we'll just throw a grade on here for now, and we need to change the grade in some way. That way it affects that source or that patch that's going over the source. Okay. Since we don't need to do any of that, we'll just go ahead and delete the merge node and set this grid warp tracker back over the source itself. When we view through that, we'll see it nice and clean. A nice feature about the grid warp tracker is that you can add adjustment grids to your originally tracked grids, meaning that you don't have to worry about destroying the information on these tracks and having to start all over again. So with that, we'll add in adjustment grid. I'm going to hide the visibility of the other two grids just by clicking the eyeball icon there. With this adjustment grid, then, we can begin to make our changes without fear of destroying original tracking data. So we can either adjust the vertices to warp and distort this image. So if I click and drag this, you can see how that affects it. Or what we can do is grab the handles that are connected to the vertexes and move those around. You can see how those distort the image. So with those changes that we just made on the single frame, because we've tracked the grid already and it's being driven by our smart vector information, we're now able to play through this, and it's going to maintain those changes throughout the entire footage. Let me just hide the grid so we can turn that off, and then I'll go ahead and play through this. Because we have the ability to add in these adjustment grids, I can add another adjustment grid on top of this. Let's go ahead and add one on top of this. We can make adjustments to our adjustment grid. And if we don't like it, we can either just disable it or delete it altogether. Connect this back into your main pipe. We'll take a look at the end of this. And then we can see our changes throughout. Let's move on to the next example. I'm going to revisit the building example here. I want to show you another function or feature of the grid warp tracker. This particular one, we're going to focus on this building in the background here. I'm going to add a Nuke logo over it. See, I got that positioned into place here. And then I just changed the blending mode to color dodge. Bring that down. What I did originally is take the smart vector and grid warp tracker, and then also just a mask over this. So we're using that as the mat for the smart vector as well as the grid warp tracker, because we really want to just focus on this area over here with this building. I added the grid, drew the grid over this, tracked it, looks something like this. All right, and grid goes off screen. Now the reason why we didn't use the vector distort or the vector corner pin was because, what happens, we've seen in previous examples, when an image comes close to the edge here, it's going to get pulled and stretched. With the grid warp tracker, that's not going to happen for us because the grid can actually go outside of the frame and maintain its shape. If it were to come back in, the grid would come back in with it as well. What we want to do then instead is take the points that are pretty stable on this grid. They seem to be these middle ones here. Take all these middle points. We can take one, we can drag multiple. But what we do is grab those points, right click, and then we can export these as a tracker that's baked, a tracker that's linked to these points, or a transform that's baked. Actually, I want a tracker. We're going to use the tracker for this. Export tracker baked. And then what I did is I plugged this into my Nuke logo here. By doing so, if we look at this now, we're going to see that this logo holds pretty well throughout the entire shot. There we go. Pretty solid track, pretty easy. Just had to add a little grid over it, track the grid, take those points from the grid and apply them through the tracker to our Nuke logo. Now let's go ahead and take a look at some of the exploratory examples of how we can use the Smart Vector toolset. Because we're short on time here, basically, rather than setting everything up from scratch, I'm just going to show you some examples that we put together here. So for this one, if we take a look at our footage that we have to work with, it's just some fabric that's being pulled. Let's actually change this to input. There we go. So it's a little bit longer. Maybe you can use the motion graphics for this instance here. So in this one, we've used the vector distort node, put some text over it, and then the end result was kind of something like this. So the motion graphics are just following the motion and the shape of the fabric as it's being pulled. Another example here is using the STMap function. So we didn't talk about the STMap function out of the vector distort, but basically, this vector distort, you can have the output set to warped, which is by default STMap or STMap inverse. Then you can use STMap information. So what we've done here is basically add a smart vector here. The vector distort node is set to STMap. Then we have the STMap node that is plugged into some kind of other texture over here, which is going to be a noise that we have set up. Gray and a little bit of roto on there. STMap is reading the UV channels there. It's coming through, and we're actually applying it to a sphere, in this instance. So you can see that information there. Add some effects on here like the low, maybe some God rays. Drop that down. So then we have something like this. We'll go ahead and play through this. Gives you kind of a neat little visual effects. Now this is all just being driven by, random texture or information like this. So whatever you're feeding into the smart vector, so we can just change the result by changing the type of footage that you're piping through the smart vector. So let's go ahead and take a look again at the end of that. And we'll switch around some of these results here. Let's go back to the beginning. That's what that looks like with the fire. Now, what if we have like the swirly thing driving this? You get entirely different results. Might not see it here in this example using the noise. So what we'll do is after this one, some flashing lights that are driving this. Kind of all looks the same, but if we play through it, you can see it kind of morphing and changing shape differently. Back through to the fire. Get different shapes out of that. Now, because I'm using noise as a texture for this, we can also plug in other different textures like this grid. So if we go to using grid, you get a whole new result. And then this is the result of using fire. And we have here, it's the God rays that are filling in there. Let's try this twirl thing and see what happens when we use the twirl. A little bit different results here as well. And we'll try these flashing lights. Different movement there as well. But at least this, this way kind of make you think outside the box of a way you can use smart vectors differently and how you can use different informations or textures or footage to drive these smart vectors and give you different warping or shifting results in conjunction with these textures that you're feeding it. So with that, I also had added in this spherical transform node. The spherical transform node, if we look through that, because I'm wrapping it around a sphere, I put it into a lat long thing format. And with this, I can actually change the position of the format if I hold down Control and Alt and drag. But then this way I can get different movement as well. And key this and have it animate in different movements. And that'll be reflected down here towards the end of that. So let's go ahead and try to just move this manually in here. But you can see as I change these values, it's changing the shape and movement of the end result there. So it's all procedural at this point. Taking this texture that we have here, another instance here, maybe just using this footage, apply an effect over her face or whatnot. Once again, smart vector, grid warp tracker. For this on the grid warp tracker, we're using a morph. So what we've done is basically added in a grid for, turn the grid on here, grid for her head, the shape of her head. And then we have a grid for the texture over here. That way we can morph between the two. That way we can really shape this texture. Take a look at that texture. We can really shape that to her head. And that's kind of what we've done here. So if we look through this, that's shaped like that, but we're going to go look at the end down here. What I will actually do is change this back over to the flame one. change this back over to the noise. Because this is all procedural, it's going to update for me over here as well. But yeah, now we can actually see some effects going on her face. And then these are sticking to her face because of the grid board tracker and the smart vectors. What we actually did here to kind of just take it a little bit further is just set it on a simple background. And then now we have an isolated effect. So it's almost volumetric. It's like fake volumetric looking thing. And it's going to move with the movement of her head because it's being driven by the smart vector. And the texture is going to change over it because all that information is being driven over here by the flame motion. So yeah, it's taking a little while to process just because we're running through this smart vector over here, running through this 3D system, running through some glows and God rays. But if I were to flipbook this, then we'll be able to get the nice end results of that. So let's go ahead and actually flipbook that. If you're not familiar with the flipbook, I'd recommend checking it out, especially if you have Hero Player. Because now you can set your flipbook to Hero Player. I'm actually only going to do maybe 5 frames of this, 1 to 5, because 520 is kind of a lot to wait around for. Let something render. All right, so great. Popped open our Hero Player for us. Now we'll be able to see this playback in real time. So this is the 5 frames we processed. All right, so that about wraps it up as far as examples of what we have for vector distort, vector corner pin, grid warp tracker, and then some unconventional ways you might use the smart vector tools. Highly encourage you, if you have access to them, to check them out yourself. Know that they can be a huge time saver. I can't emphasize enough that you really need to use the right tool for the right job. I'd like to acknowledge the videos used in this demonstration. I find Pexels.com to be a great resource for free videos, and there are many contributors on there that don't expect anything in return for using their video content. That brings us to the end of our presentation. I want to thank all of you again for joining us today and staying with us until the end. If you enjoyed this presentation or are curious to learn about past or future presentations from Foundry, please check out foundry.com/events/virtual-events. Thank you again. Now I'll hand it over to Martin to answer some of your questions.
All right. So, hello everyone. This is Martin from the Foundry. And I'm happy to answer any questions that you might have.
Awesome. Martin, shall I go ahead and start picking out questions for you?
I went through the ones that were in the question section as we were. So if you...
looks like you've answered a lot of the questions. So why don't we just go through them individually, just so people, in case some of them haven't read some of the answers. Just going to look at which ones. So there's a question from Adam Tennant. When are we getting built-in frame hold that selects the frame you're on?
Yeah, so currently there are really no plans for that, but something like this can be really handled by a script or an expression. That's the route I would probably choose. It can be triggered by the creation of the tool. For example, it picks the frame that you are on at that time.
Awesome, perfect. So Lee Watson, he asked a question. Is there a good way to avoid vector smearing when your source moves in and out of the frame? Example, if this person's face moved to the edge of frame and back in, how would you manage the smart vectors?
Mm-hmm. So DJ was covering some of this in the actual webinar, but I would probably resort to few vector distorts and then blend between them. It really depends on the shot. That would be possible.
Sure thing. Perfect. So this question might actually be for me mainly. Is this play available to download and use? Try to practice smart vectors. Oh, sorry, I chose the wrong question. But
DJ had a list of things at the end of the webinar where you can actually go and download all of these.
Perfect. Thank you for that. And there was, so I'm just going through the questions. Arthur asked, does the cropping part the image before calculating the smart vector save processing time?
It does. Well, less pixels, the faster it will be. The less pixels you process, the faster the whole process will be. Although with some of the recent graphics cards, things are pretty speedy already. I saw a question in the chat window. So what was the name of the webinar instructor? It was DJ Matias. He goes by DJ. He's one of the members of staff in the Foundry. Yeah.
Perfect. Let's see what else there is. There's one that Aniket Kesarker asked, which minimum budget graphics card do you recommend for Vector Dessort node?
That is a little tough. I mean, it really, whatever your budget allows, but generally what matters the most is the amount of VRAM it has, so it can actually crunch the data in the memory while it's doing its thing. And the rest is really just the processing speed. So obviously, the faster chip, the faster the whole thing will be. But the limiting factor will be the VRAM.
Awesome. I'm going through all the questions, and it seems like all of them have been answered. And I know we're a little bit tight with timing as well. So let's see one more time if there's any open ones that we haven't gone through. No, it seems that we've covered all of them. So I think we can leave it at that for now. Thank you everyone for joining. If you have any more further questions, as I said, send us an email on virtual.com. The virtual events email. I'll drop it in the comment section in a moment. Other than that, thank you very much for joining, guys. I hope you enjoyed this webinar and it was insightful for you guys. Stay safe wherever you are. Have a wonderful day, evening, night, wherever you are in this world. Take care. Goodbye.
Take care, everyone. Have a good one.